Introduction to Composite Restorations.
Hello, my name is Katrina Tarangai, and today I'll be discussing Introduction to Composite Restoration and important composite properties.
Hello there, I am Grassel Symbol, and I will be the one handling principles of adhesion, bonding, and sealing in dentistry.
Hi, I'm Dwayne Tyson, and I will be the one discussing the types of aesthetic restorative materials.
Hello, I am Carlo Tagab, and I will be discussing advantages and disadvantages of composite resin restorations.
Composite restorations are versatile, tooth-colored filling materials, composed of strong plastic and glass particles that are used by our dentists or dental therapists to seal deep fissures, fill cavities, and sometimes restore extensively broken down teeth. It is also to match the natural aesthetics of your adjacent teeth. What does composite mean in dentistry? A composite filling is also known as a filled resin. The filling itself is made up of quartz or a glass filler. The dentist can customize it so it matches your natural tooth color. A composite filling also lasts for a long time. You can get this type of filling for a small to medium restoration of your teeth. Again, what is composite restoration used for? Just like dental amalgam, they are used to restore tooth structure lost through trauma, caries, or other diseases. Composites can also be used as cements to cement crowns and veneers, etc.
Principles of adhesion, bonding, and sealing in dentistry. What is meant by adhesion, bonding, and sealing? Adhesion, bonding, and sealing are the processes of attaching substances to each other, such as dental bonding and sealing. 3 types of adhesion are possible at the interface. Mechanical adhesion involves interlocking the roughened surface of 2 substrates, while physical adhesion involves molecules with different charges at ends of the molecules. Chemical adhesion involves different components bonding to the substrate, while failure occurs within one or the other. Dentin bonding system consists of 3 components: etchant, primer, and bonding agent. Dental adhesives must be hydrophilic, less viscous, and have good micromechanical interlocking with the substrate for superior bond strength. Dental sealants are thin coatings that, when painted on the chewing surfaces of the back teeth molars, can prevent cavities tooth decay for many years. Sealants protect the chewing surfaces from cavities by covering them with a protective shield that blocks out germs and food.
Types of aesthetic restorative materials. Although these materials are referred to as resin-based composites, composite resins, and by other terms, this refers to most direct aesthetic restorations. Composites are a major advancement in restorative dentistry, allowing for improved aesthetic restorations. Firstly on the list is ceramic inlays and onlays. Fused feldspathic porcelain has been used for indirect ceramic restorations since 1908. 2. Silicate cement. Silicate cement was used for more than 60 years to restore caries, lesions in anterior teeth, with high fluoramide content and solubility. 3. Acrylic resin. Acrylic resin was developed in Germany in the 1930s, but had poor activator systems, high polymerization shrinkage, and wear resistance. 4. Composite. Bowen developed a polymeric dental restorative material reinforced with inorganic particles to improve physical characteristics of unfilled acrylic resins. Composites are classified based on the size, amount, and composition of the inorganic filler. 5. Macrofill or conventional composites. Macrofill composites have a rough surface texture and higher initial wear at occlusal contact areas than hybrid composites. 6. Microfill composites. Microfill composites are designed to replace conventional composites with a smooth, polished surface that is less receptive to plaque and extrinsic staining. 7. Hybrid composites. Hybrid composites combine macrofill and microfill properties for superior physical and mechanical characteristics. 8. Nanofill. Nanofill composites have high filler levels and polishability, making them popular restorative materials. 9. Flowable composites. Flowable composites should be used in small class 1 restorations. as pit and fissure sealants, as marginal repair materials, and as bulk fill materials. 10. Glass ionomer. Conventional glass ionomers. Glass ionomers release formid and possess a favorable coefficient of thermal expansion, making them suitable for root surface carries and other restorations. Resin-modified glass ionomers, RMGs, are easier to use and possess better strength, wear resistance, and aesthetics than conventional glass ionomers. 11. Compomers polyacid modified composites. Compomers have superior physical properties, but limited clinical use. 12. Packable composites, increased viscosity and resistance to packing hinder optimal marginal adaptation.
Important properties of composites. The various properties of composites should be understood for achieving a successful composite restoration. These properties generally require that specific techniques be incorporated into the restorative procedure, either in tooth preparation or in the application of the material. The various property factors are presented here with additional information provided. 1. Linear coefficient of thermal expansion. Bonding a composite to etched tooth structure reduces the potential negative effects of the difference between the LD of the material and the tooth structure. 2. Water sorption. Water sorption is the amount of water a material absorbs over time, affecting its properties and effectiveness. 3. Wear resistance. Tooth-colored restorative materials is generally good, although not as resistant as amalgam, and offers stable occlusal relationship potential in most clinical conditions. 4. Surface texture. Surface texture is essential for optimal gingival health, and nanohybrid and nanofill composites provide smooth surfaces that are polishable and compatible with soft tissues. 5. Radiopacity. Restorative materials must be radiopaque to be visible in radiographs. 6. Modulus of elasticity. Higher modulus of elasticity is more rigid, while lower modulus is more flexible.
Advantages and disadvantages of composite resin restorations. Advantages. 1. Aesthetical compliant. 2. More discreet in tooth structure removal, less extensive removal, uniform depth or mechanical. Retention not required. 3. Has low thermal conductivity. 4. Good bonding with tooth structure leading to less micro-leakage and better retention, minimal interfacial staining, and increased strength of remaining tooth structure. 5. Repairable. 6. Simpler tooth preparation. Disadvantages. 1. Gap formation may occur due to polymerization shrinkage, or improper insertion of the restorative material. 2. More difficult, technique-sensitive, and time-consuming due to involvement of multiple procedural steps. 3. More costly. 4. Increased probability of occlusal wear in areas with high occlusal forces. 5. Can lead to marginal percolation in cases of improper bonding of the cement due to a higher linear coefficient of thermal expansion. 6. Low fracture toughness.
Help you learn something about a dictator.